Every code you see or every code you write in a project is not necessarily an algorithm. In fact, every logic is not an algorithm. So for example, logic like updating or deleting a record from database is not qualified as algorithm. So what exactly makes a logic an algorithm? And now I'm going to share 5 key characteristics that makes an algorithm. The first is clear inputs. You should make crystal clear what's going in. And the second is clear outputs. Similarly, the output of an algorithm should be clear and well defined. And third is specific steps. Every step in an algorithm must be precise, straightforward, and to the point. For instance, if you're adding 2 numbers, the process is simple. First, input number 1, and then input number 2, and lastly, add them together. Simple, right? And the fourth point is finite steps. An algorithm should have a limited defined number of steps. And finally, uniqueness. Each step in an algorithm should be unique. Usually, the output of one step becomes the input for the next step. So these are 5 main characteristics that really define an algorithm. And remember, when we talk about algorithms, big O notation often comes up. It's a key concept and used to define how efficient an algorithm is. But before I dive deeper in big O notation, let's take a step back and let me share an example with you. It is one of the questions that asked in many job interviews. The question is, how would you find the first non-repeating character in a string? And here is the complete code. The problem is an excellent example of an algorithm because it involves precise input, in this case a string, clear outputs, in this case it's the first non-repeating character, specific and finite steps, and each step's output feeds into the next step's input, as you can see. Before I explain exactly how this algorithm is working, let me explain a key point about the data structure. The selection of data structure, the use of this line in the C# code is a strategic choice for solving the problem. Dictionaries in C# are implemented as hash tables, which means they can provide very fast lookup. When you need to check if a character is already in the dictionary and update its count, this can be done in near constant time, regardless the size of the dictionary. And this is crucial to keep the algorithm efficient, especially for long inputs. A dictionary in C# is a collection of keys and values. In our case, the key is a character and the value is a number of times it occurs. For example, this is how the hello world string will be stored in the dictionary. Each row of the table shows a character from the string and then the number of times it occurs. Okay, now let's quickly talk about how this algorithm is working. Here I am initializing a dictionary to store the count of each character in the string. And here iterating through the string and update each character's count in the dictionary. And now identifying a non-repeating character. Iterate through the string again. For each character, check its count in the dictionary. If a character with a count of 1 is found, indicating it does not repeat, return it as a first non-repeating character. And if the entire string is iterated and no repeating character is found, return a special character. And in this case, I'm returning a null character. And now let's dive into the big O notation, a fundamental concept in understanding the performance of an algorithm. In simple words, big O notation is used to measure how running time or space requirement for your program grows as the input size grows. And big O notation is machine independent. So the real focus is number of steps it takes to complete the algorithm. And why big O notation is machine independent? Because some machines are fast and they can execute the algorithm fast. On the other hand, if you run the same code on a slow computer, obviously it will take more time. And that's why big O notations are machine independent. In the context of our non-repeating character finder, the big O notation comes into play in 2 key areas. The time it takes to count the character and the time to identify the non-repeating character. And here are the few examples of big O notation. And here n represent the input. Let me talk about 3 most common big O notations. The first is constant complexity. Regardless of the problem size, the algorithm always takes approximately the same amount of time to execute. And it is represented by O of 1, constant complexity. And the second is logarithmic complexity, and it's represented by O of log n. The execution times increases very slowly as the input size grows. And finally, linear complexity, and it's represented by O of n. The execution time grows in proportion to the input size. And for the character counting part, we iterate through the string once. This means the time it takes is directly proportional to the length of the string, and making it O of n, where n represents the length of the string. Similarly, for identifying the non-repeating character, we iterate through the string a second time. This is also an O of n operation. So when we combine these two steps, the overall time complexity of an algorithm remains O of n, linear complexity. This is because the big O notation, we focus on the largest term, and here the largest term is still n. It is really important to understand that big O notation is not about the exact number of operations or the precise times in seconds. Instead, it's about how the numbers of operations scales as the size of the input increase. Big O notation helps to understand scalability and efficiency of an algorithm. For our specific algorithm, with the big O notation, O of n, we can confidently say that it scales linearly with the size of the input, which is a desired characteristic in many practical operations. Do you know that in this example I choose dictionary, but we can choose hash table or array list or some other data structure. The choice of data structures significantly influence the algorithm performance, and big O notation helps to quantify the impact. If you really want to know how to choose data structure wisely, there's already a video on it, and the link in the description. And thanks for watching.